Have you ever wondered how your computer's operating system works? Well, you're not alone. It's like a symphony, with each part playing a crucial role to create a harmonious whole. We call this the computer system structure. It's a fascinating world of hardware, operating system kernels, device drivers, system libraries, user interfaces, system services, file systems, and memory management units. Each of these components has a unique function, but they all work together to provide you with a seamless computing experience. Our journey today will take us through each of these components, providing a comprehensive yet easy-to-understand explanation of how they interact with each other. Whether you're a seasoned system administrator or someone who's just curious about how your computer works, there's something here for everyone. So let's dive right in and start by understanding what hardware is. Think of hardware as the physical parts of the computer that you can touch. These are the tangible components that make up a computer system. Let's break it down. Firstly, we have the Central Processing Unit, or CPU. This is the brain of the computer, where most calculations take place. Then there's the memory, or Random Access Memory, RAM. This is the computer's short-term memory, where data is stored temporarily while being used. Next, we have storage devices like hard drives and SSDs. These are the computer's long-term memory, where data is stored permanently. Input and output devices such as the keyboard, mouse, and display allow us to interact with the computer. Lastly, we have networking hardware like network interface cards, routers, and switches, which enable the computer to connect to other devices and the internet. Each of these components plays a crucial role in the overall functionality of a computer system. Now that you understand what hardware is, let's move on to the operating system kernel. The operating system kernel is the heart of your computer, controlling everything that happens inside it. Imagine it as a diligent manager. It oversees all the resources of your computer system, including the CPU, memory, and devices, ensuring everything works together smoothly. The kernel is also responsible for providing essential services. Let's break these down. First, there's process management. The kernel decides which processes get the CPU's attention and when. Then there's memory management. The kernel keeps track of each byte in a system's memory and who's using it. It also manages device interactions. When an application wants to send data to a device, it sends the data to the kernel. The kernel, in turn, sends this data to the device. And finally, let's not forget file systems. The kernel manages how files are created, read, and written on your computer's storage. Next, we'll talk about device drivers, which act as translators between your hardware and your operating system. Device drivers are like interpreters, helping your operating system and your hardware to communicate effectively. Imagine trying to give instructions to someone who speaks a different language. Without an interpreter, the communication can be quite tricky. Similarly, an operating system uses device drivers to send instructions to hardware devices. Every piece of hardware, from your keyboard and mouse to your printer and graphics card, requires a specific device driver. These drivers translate the operating system's instructions into a language the hardware can understand. They also send data from the hardware back to the operating system. This two-way communication allows the operating system to control the hardware and respond to its status. Device drivers are crucial for the smooth operation of a computer system. They provide the bridge between the software and the hardware, enabling them to work together seamlessly. Without them, your operating system wouldn't be able to utilize the hardware effectively. Moving on, let's discuss system libraries. System libraries are like a toolbox, providing useful tools that software can use. These libraries are collections of pre-made code that applications can call upon to perform common functions. Imagine you're building a house. Instead of creating each brick from scratch, you'd probably prefer to have a pile ready to use. In the same way, system libraries save developers time by providing pre-written functions for tasks like reading and writing files, connecting to networks, or creating graphical elements. Not only do libraries save time, they also abstract low-level hardware interactions. This means developers can focus on the unique parts of their application without needing to understand the nitty-gritty of how the hardware works. For instance, a library function could handle the complex task of drawing an image on the screen, while the developer just needs to specify what image to draw and where. And so, system libraries are a crucial part of our computer system structure, serving as the bridge between hardware and software, making the developer's life easier. Next up is the user interface, the part of the system you interact with the most. The user interface is your gateway to interacting with your computer's operating system. It's the first thing you see and, most likely, the aspect you interact with the most. There are two primary types of user interfaces you'll encounter: command line interfaces and graphical user interfaces. Command line interfaces, or CLIs, are text-based. Here, you input commands through lines of text, a method favored by many developers and system administrators for its precision and control. It might seem intimidating at first, but once you've mastered it, the CLI can be a powerful tool. On the other hand, graphical user interfaces, or GUIs, are more visually oriented. They present you with windows, icons, menus, and buttons that you can interact with using a mouse or touch. GUIs are user-friendly, intuitive, and ideal for those who prefer a more visual approach. In both cases, the user interface is key to how you interact with and experience your computer's operating system. Now let's explore system services, the unsung heroes of your computer's operating system. System services are like the backstage crew at a theater, working behind the scenes to keep everything running smoothly. They are the background processes and services that the operating system provides to support various functionalities. They're constantly running, diligently maintaining the system's overall performance and functionality. Think of system services as the silent heroes, aiding in process scheduling, the technique of planning the execution of processes in an operating system. They also manage security, keeping your system safe from potential threats. Ever wondered about the mechanisms that allow you to connect to the internet? That's your network services at work, handling tasks like dynamic host configuration protocol and domain name system. And lastly, system logging. This is the process of recording system events and activities. It's like a diary for your computer, providing a detailed record that's invaluable when troubleshooting issues. Finally, let's discuss the file system and memory management unit. The file system is like a library, organizing your data into files and directories. Just like how a library classifies books under different sections and shelves, the file system structures data on storage devices. It provides a hierarchical structure for arranging files and directories, making it easier to locate and access them. This file system doesn't merely store data, it also defines rules for data access and manipulation. It allows you to create, read, write, and delete files, and it manages the allocation and freeing up of space on the storage device. It's a vital component that ensures the smooth operation of your computer. Now let's talk about the Memory Management Unit, or MMU. This is a crucial piece of hardware that manages memory access and virtual memory. Imagine a city with numerous buildings, each with multiple rooms. Now consider the MMU as a city planner who maps out which rooms are allocated to which residents, ensuring efficient use of space. The MMU translates virtual memory addresses used by applications into physical memory addresses. This process is much like translating a building's name and floor number into a specific physical location in the city. This translation allows applications to work with memory in an efficient and protected manner, without needing to understand the complexities of physical memory management. Moreover, the MMU enforces memory protection. It's like a security guard that ensures each resident only accesses their allotted rooms, preventing unauthorized access. This protection is vital as it maintains the integrity and reliability of the system. The file system and the MMU are two key components that work together to manage data and memory access in a computer system. They ensure that data is well organized, memory is efficiently used, and system integrity is maintained. Now that you have a better understanding of the different components of a computer system structure, you're well equipped to manage, optimize, and troubleshoot your computer. So, there you have it. A simple and comprehensive guide to understanding your computer's operating system. We've traveled through the intricate landscape of hardware, explored the core functionalities of the operating system kernel, and delved into the crucial role of device drivers. We've seen how system libraries provide reusable code, easing the developer's task. And we've touched on the user interface, your gateway to interacting with all these complex systems. We've also looked into the unsung heroes, the system services that work tirelessly in the background. And finally, we've learned about the file system and the memory management unit, both integral to how your computer organizes and accesses data. Understanding these elements and their interactions is key to effectively managing resources, optimizing performance, and troubleshooting hardware and software issues. Thank you for joining us today, and stay tuned for more enlightening discussions on all things tech.